Good morning, good afternoon, happy Wednesday or not, but for us it's Wednesday afternoon. Sometime. Oh, it's July. It's July. Hey,
July 1.
July 1. All right, well, whatever. That doesn't matter because you're probably watching this video in like October or November or something. Anyway, we're going to continue on with chapter 5 and start talking about some properties of the logarithms. And if you notice, now we have fully rotated around and we're upside down, or at least our names are.
They probably didn't notice until right now.
Oh, yeah, they didn't notice the names being.
In fact, I bet a whole bunch of them just rewinded to see what you were talking about.
They don't know what I'm talking about. All right. So we'll begin with the product rule for logarithms. I would like for you, I did lie. I told you we were going to need a calculator, but I do. So let me get to, oh, look at my beautiful motorcycle. Where's my cat? Come on, cat. All right. So what I want, and I had this on the screen. Oh, I got to make a new document. Actually,
you've got boxes of numbers on your screen.
Yeah, I was doing
boxes of numbers.
Boxes of numbers and stuff. Oh my goodness. What is happening is the fact that
You're not ready.
I'm not ready. Okay, we're adding a calculator. So we want to do log 5 and plus log 4. So I wanted to do log, I think it was 4, and then plus log 5.
Guys, don't forget that he's leaving those space boxes empty because the base is 10. He could absolutely type 10 into those boxes. It's just a waste of time. See, it'll put it
there for me. Yep. And then if I believe the question asked me to do log 20, and I may have the 5 and the 4 backwards, but if I remember, those were the two numbers from the screen a moment ago. And then I asked you to enter log 20.
Oh my God, it's the same amount.
It's the same thing. Wow, it's crazy.
What?
It's almost like I knew what I was doing.
If you do log 4 divided by 5, is that the same too? If I use those 5s in any way I want, wait, go back to the calculator.
I'm going back to the calculator. Hold on.
What happens if we do log of 4 plus 5? Is it the same?
Log of, in the parentheses, like 4 plus 5 in here?
Is 4 plus 5 the same? Not minus.
You know what? I can't hit the right buttons. Not so much. All right. Well, what else? What other way can I use numbers? You want to play with another relationship, maybe?
Well, I mean, I would have thought that log 4 plus log 5 was the same thing as log 4 plus 5.
Yeah.
So what you're saying is that log 4 plus log 5 is the same thing as log of 4 times 5?
So you want to do that? All right, let's try that. We're like goofing around here. So you want to say log of 4. You want me to put the 5 afterwards like this? Or the 5 in front?
I mean, you can do this.
I can do this. Okay. Not the same.
Oh, gosh. So how do you got to make 20. Let's do 4 times 5 in the parentheses like the 20 is in the parentheses.
Okay. So if I do that, this I think will work because if I do 4 times 5, silly goose, what's 4 times 5? Oh, that is the same as it was. But 4 times 5 is 20, right? So couldn't I have just saved myself the grief and said log base 10 of 20?
Mr. Bobby, but if we're trying to teach them what these things mean, we probably should talk about them.
Yeah, I know. I agree. But now, so, okay. So I can't, add, but what's the relationship between this one I've got highlighted in blue, the connection? Is there any other connection? What do you notice between that and this?
So they kept the base.
Kept the base, yeah.
The base. And we didn't do 4 plus 20. 4 plus 5, because that would have been 9.
Yeah, then we tried that because this would have, down here, that would have ultimately been log of 9, right?
Yeah. So what we're saying, though, is that, log of 20 is equal to log of 4 plus log of 5.
Right.
Will that always work? Is it just working because of 4, 5, and 20?
Okay.
What
do you noticing about the relationship between 20, log 20, and log 4 plus log 5? Is there a way to connect them?
Well, I hope that we see that if I want to put 4 and 5 together to make 20, that it's 4 times 5.
Okay, 4 times 5 is 20.
So you're saying that I can go from 2 logarithms to 1 by just
from 1 to
multiplying
2,
those?
if I make
Or,
these numbers match up so that they multiply to make the number in the single logarithm. So what's
so like,
another way to make
had,
20 out of a multiplication problem?
so like if I did log of 2, ooh, I need to do a plus sign, right?
Okay,
Plus log of 10, would that be the same amount?
well, let's find out. And what'd you say, 10? Okay.
Right, because 2 times 10 is 20.
So you're making a theory that that's going to come out the same thing?
Yeah. Okay, okay,
All right,
okay.
so 4 times 5 multiply to make 20, and 2 and 10 multiply to make 20. So any two numbers that I put in those boxes, in those logarithms that multiply to make 20 should give me the same thing, right? So like 1 and 20, right, would work.
What about what's
So do you want me to do that? 1
yeah, sure.
plus, okay. Let's make a hard one though.
Which makes me think that like if log of 1 plus log of 20 is the same thing as log of 20, that's interesting about log base 10 of 1, isn't it?
Yeah, we did that in the last section. Log of 1 is 0. We talked about that with the graph. Remember, it had the intercept 1, 0. So that
I remember now. I
yeah,
remember.
that makes sense. So like, let me get really freaky out here now and try like, I don't know, 20 divided by 3 here. Except I
Yeah.
want 3 there. I'm just spitballing an idea out here. And they're probably like, we already know this probably, but what number do I need to multiply 20 over 3 by to get 20?
Times 3, of course.
Of course. And it works. Okay, because 20 over 3 times 3 is 20. So, all right, that's our property. And it works with numbers, and actually it works with anything that I would put in there. And this is called the product rule for logarithms. Okay? And it's actually related to your old friend, the exponent rule. When you multiply, you add the exponents. Remember this from your exponent rules. So and a logarithm is the exponent. So when we taking the logarithm of a product, we can split it up as the addition of the two exponents. It really is this kind of rule here. And I could pull it apart or I could combine it. Okay? So let's look at a couple examples here. So I've got, what would be a way that I could combine 7 and 8? Well, what's 7 times 8? Oh gosh, now I got to do math after being
56.
86. All right, log base 5. I actually know what 7 times 8 is. Okay, now do you need to actually write that step? No, you're smart enough to know that's 56. Okay. All right, Miss Smarty Pants. Oh, I didn't realize I missed.
I had myself doubting myself for a second. I said 56, and then I was like, oh, wait, is that right?
Let me explain something to y'all. Miss Young and I put in a full day. Like, we have our normal jobs, and we've been doing our normal jobs, which are actually super busy in the summer. And
Yeah.
it's like 4:30 or something on after we've put in a full 8-hour day, and now we're going to talk about logarithms. Okay. So, all right, Miss Young, I got a trick problem for you there.
I think it's log base 15 of 3 plus r.
Good one. Good try, but no.
No.
What
do we do when the bases aren't the same?
What do you do if the bases aren't the same? If you notice in the logarithm rule, this A has to match up to these two. So you know what this is? This is log 12 of 3 plus log 3 of r. Come on, why are you not working? That's it. I can't do nothing. If those bases don't match up, you can't play, they don't play nice. Those subscripts or those bases have to be the same because you know why, Miss Young? Come on, say it. Say it. You know you want to say it. It's all about the, never mind.
It's all about the bass, about the bass. No trap. Okay, I'm done.
All right. I don't even know that song. That song's too old. All right, what
They
about,
know that song. They know it.
all right, are the bases the same now?
The bass is E because it's the natural logarithm.
It's the log without the mark problem. So this one would be the natural log. And then what do I do with those variables? I can't multiply them.
Yeah, you can. What are you talking about?
Well,
Willis?
I can't get 56 now.
You can get x cubed times y to the fourth, though.
And that's as far as I can go. Okay. So moving on. And Miss Young is texting while I'm trying to teach here.
I know, I'm sorry. If it makes y'all feel any better, it's Mr. Campbell.
Yeah, we're actually trying to get stuff so that we can actually continue to do our jobs for you guys. Which are official now. We actually are like officially employees as of today, right? Like
We're officially you guys's.
yeah. I mean, like we've been working before we were getting paid. So anyway, all
Yeah,
right.
how much we love.
So do you want me to actually go back to the calculator and do this, or you?
No, I think they get the point. Like relationships and logarithms are weird and funky. They relate to relationships with exponents. And so we could go back to the calculator and we could do that same thing where we play with the numbers.
Yeah.
But really what happens is if you are subtracting a log minus a log where the bases are alike, what's going to happen is the input of the logarithms will actually get divided in a single logarithm.
So that one becomes 20 divided by 4, right?
Right.
And what's 20 divided by 4? That
5.
gets me back to the 5 over here.
Yeah.
Right? Okay, back over here. Now, what other way? Is there another combination that I could have done to get 5 besides 20 and 4? Just think about one, come up with one in your head.
You want me to, or do you want to?
I give them a pause for a second, but now go ahead. What do you think? Is there another one that I could have used as an example instead of 20 minus 4? Natural log of 20 minus natural log of 4.
Oh, natural log of 15 minus natural log of 3. That wasn't very interesting, was it?
No, that was pretty boring. But, we've come to expect the boring out of you.
Wow, that's just
We don't
rude.
even have sparkly shoes, all right?
I'm wearing socks today, though, which is more than normal.
Yeah. Oh, and did I tell you I got 3 new pairs of shoes yesterday?
I'm sorry, did you say 3?
No, I'm sorry, 5. I said the wrong number. I got 5 new pairs of shoes in the mail.
You have a problem.
I have shoes.
Oh, no. No, you didn't.
I just did. All right, so we can combine them or we can pull them apart, and we're going to do a little bit of both here. So I have one where I've got a logarithm of something divided by something, and I want to break it apart into the 2 pieces. So what I'm going to end up with is log 3 of x to the 3rd.
The base is 5.
I said 5. Yeah, that's the first mistake ever. Okay. Because it's all about
Miss Young.
It's all about Miss Young. No, it's all about the base. Come on, dance for us again. I dare you.
Sprinkler?
And then what's the other term would be y to the 4th.
Right.
All right.
Kind of the hint on what you should do when you see a problem like this is like, if there's one log, we probably want you to go from one log to more than one. If there's many logs, then we probably want you to put it all together to go to one log. And you're always trying to figure out like what's happening inside the logarithm to help you know what the next step is. So like natural log of 6/7, you should say, oh, I see a division bar. And so if I wanted to write this with more than one logarithm, I would do natural log of 6 minus natural log of 7.
Your face was over the natural log of, where the natural log of 7.
Well, I'm kind of hungry. I was thinking about eating it.
Eating those 2 logs. So anyway, okay. So I can break it up. I can break it down, Now, what if there's separate ones separated by a subtraction? We're going to combine them. We can go the other direction. So what about natural log of 42 minus natural log of 7? I'm going to combine it as one logarithm, but 42 over 7. So I would get natural log, or sorry, I'm doing log
I was
base.
to say we're now doing log base 3.
I'm sorry, we're in log base 3. 42 divided by 7. And like when I did it with x's and y's in the previous problem, I couldn't simplify it using any algebra or any numerical method. But if you can, I would enjoy it if you would. 42 divided by 7, last time we checked, is 6. So it would be log 3 of 6. Okay?
I think that's beautiful.
Groovy, great. All
Just-
right, one more rule. There's 3 rules. There's the product rule, there's product rule, the quotient rule, and then the power rule. Likewise, if you take log of 81, if you plug that in your calculator, you'll get some icky decimal. And then if you do 2 times log 9, you'll get the same thing. And if you do 4 times log 3, you'll get the same. And this is when you have a power to a power. Remember, logarithms of power, you ended up multiplying the powers. So we're multiplying.
Yeah, so in your head, you should be thinking like 81 and 9. How can I go from 9 to get 81? Well, it's not 2 times 9, but it is 9 times 9, which we would write as 9 squared. So what you want to think about is like this multiplier on the outside is really just another exponent. So, think about like pulling that multiplier out front into the exponent, right? And then 3 to the 4th power is also 81 because 3 times 3 is 9, times 3 is 27, times 3 is 81.
Or I just grab my calculator and check it. Or look at my power chart. I have a power.
Yeah. Another way to think about this, and you guys may hate me for this, but 2 log 9s would really just be log 9 plus log 9, right? 2 log 9s. And we already talked about this, log 9 plus log 9. We can pull that together and say, okay, well, that's log of 9 times 9.
Wait a second. I can combine these rules?
You absolutely can.
Wow.
And so then that becomes log of 9 squared. So what is actually happening with this number out front is it's telling you how many times you're adding up the log, which is actually multiplication, and repeated multiplication is actually an exponent.
Wow, so like I got 3 rules and I can use them like interchangeably or use them
However you want to use.
however you want. Oh, right. So let's apply that rule. So like Miss Young thinks about, once you really understand it, it's like not as freaky as you really think. But basically when you have an exponent here, we're going to essentially dump it out front, right? Yeah. So I could rewrite this as 3 log 8 of 6. You know what? This actually goes back to like when I was in school, like in the BC days. This thing can do all the decimals, but back in the before calculator days, I had to like look this up in the back of the book. There were like tables and stuff.
Table, I know.
Yeah, you probably never had to do that. You're not that old. So
yeah, you're way older than me.
I'm like way old. Yeah, I'm like dirt and stuff. I'm like 7 years older than you. All right. So, all right. I ain't got no exponent in log of 25.
Yeah, you do.
No, I don't. I got 25. It's so.
Well, why don't we just rewrite 25 as 5 squared?
Yeah. Like I should know some things about numbers. So then I can bring that 2 out front. Now I want to notice Miss Young didn't put a parenthesis around her stuff. Okay, I put parentheses around it. Like she didn't do this back here. It's not wrong to not put parentheses around that 9. Okay. It's not wrong, but it kind of like helps me see them doing the logarithm of something, but I won't mark you wrong. I'm not like, okay, so whatever. All right, then that makes this last one 7 natural log of x. If I get it in, if you don't want to put the parentheses there, I will resist the. How do you make your x's? Do you do it like this? Like this? There's a whole thing on the internet about the way you make your x's.
Yeah, both of mine go down.
Yeah, because there are people who do it like this, and they're like aliens or something.
I don't like it.
I don't like it either. But there's like 8 different ways you can do your X, and apparently tells you something about your personality. Did you? Am I the only one who's ever seen that? Have any of you seen it?
I haven't seen it. I don't know what you're talking about.
No, it's on Facebook, so it's probably nobody except grandma.
They haven't seen it then, because Facebook's for old people.
Facebook is for grandma. All right. So let's do a couple where we're doing more complicated ones where we're using multiple rules to either pull them apart or combine them. So here's an ickier problem that's got multiple rules within one.
Can I say what I see?
What do you see in the first problem?
I see a fraction.
Okay.
Division.
Okay.
I see 8 times x to the 4th, which is a product. I see an exponent of 4, which I know I can do something with. And I even see a square root on y. And I think that's an exponent too.
Mm-hmm. So now, like, you're seeing it all in one step, but you're like a super genius or whatever. You're an evil genius, okay? So I can only do one thing at a time because I'm just a simple motorcycle riding, maniac. So I see the fraction first, right? And once I see that division, then I know I can break it down. Oops, back up. I see the division there, and so I can break it apart as subtraction, all right? So if I do this, I'm going to do log 7 of 8x to the 4th, and then minus the natural or the log base 7. And I agree with her. I'm going to, because I know I'm probably going to be looking ahead, I'm going to write that as y to the 1/2. Y to the 1/2 is the same thing as the square root of y, right? So, I mean, you might be able to do this in fewer steps than me, but I'm giving you an insight to how I think about it. So that's legit using the quotient rule piece. Then in the first logarithm, I see a product. So I'm going to break that down as an addition. Log 7 of 8 plus log of 7 x to the 4th. That's using the product rule. And now I can deal with those exponents using the power rule. So I have to rewrite it all again. Miss Young would have been done 2 steps ago.
But guys, for real, if you're going to do this, in this order does actually matter. So first pull apart the fraction, then pull apart the products, then pull out the exponents. If you're not careful, you'll pull this 4 exponent out right here and put it in front of a log with an 8 and the x. And so I'm going to take just a minute while he's finishing that up and talk a little bit about what you would be doing if you did it this way. So if I take log base 7 of 8x to the 4th, and I yank that 4 out front, and I now call this 4 log base 7 of 8x, what's wrong with that, Mr. Bobby? What's that telling me now as a math person?
That 4 applies to both the 8 and the x, where the exponent is only attached to the x in the original problem.
Right. So notice that the only log the 4 should be attached to is the log with the x in it. And the log with the 8 doesn't have a 4 in front of it because that power of 4 doesn't apply to it. 8 has a power of 1. So we shouldn't expect to see a 4 in front of that logarithm. This would be wrong.
The last thing you should deal with is the exponents.
Right.
Always save the exponents to then. Even though it's like, oh, I can just throw that up front. it could blow up in your face. So I could have like gone straight to the second line, and you might could have too, but never do the exponents until the last step.
Right.
Okay. So using that logic, I see a fraction, which means I'm going to have to write this as a subtraction. Okay. So we're going to get, let's see, is it natural log of x minus
It is a natural log. It's
what?
the common log.
Common log. I said the wrong thing, didn't I?
And wrote the wrong thing.
My iPad is freaking out on me and being super slow. Okay. And that.
We're going to pretend like this was originally natural log.
Oh, I'm sorry. You were trying to tell me I was doing it wrong, and I was. I got you now. It's common log. All right. Right now, I understand what you were saying. It helps to understand. All right. So now I've separated it, and I could go back to 2, whatever.
Oh, gosh.
You're making it so worse. All right. Now I can pull those exponents out front. Okay.
Yeah. And guys, the fact that there is a subtraction inside this log is totally fine. It does bother some people having that subtraction sign inside the log, but it's really, it's fine. You only want to pull apart multiplication and division inside the log. Leave addition and subtraction alone. Okay.
Yeah, I put this problem on there in purpose because you're going to be tempted. You're like, ooh, I got more junk in that parenthesis that I can split up, but I can only split it up if it's multiplication or division or exponents. If there's an addition or subtraction, let it be. Be like Paul and let it be.
Let it be.
All right, last slide, I think. So, move on. How about I move on? Going the opposite direction, if we have an expanded form or a bunch of them, we want to mush it back together. And what we just told, like, since this is the opposite direction, we want to deal with those exponents, those coefficients to become exponents first. Right. So when you're breaking it down, deal with the exponents last. When you're putting it back together, you got to deal with them first. So I've got a 2 and a 3. Those got to go inside as exponents. So I would then write this as log 8 of x squared. Okay.
So he's taking these coefficients on these logs and he's pulling them in as exponents. So that's log base 8 of x squared plus log base 8 of y cubed.
Apparently, I'm not the only one that's tired. My iPad and my internet is tired. I better stop using so much internet so I can watch Hamilton on Friday.
And so what's going to happen now is we have a log plus a log, and 2 logs added becomes 1 log with multiplication. So this becomes log base 8 of x squared times
Thank you.
Y cubed. It's okay.
My iPad.
That's why we're working together.
Yep. Okay. So we're going to put them together, pull those exponents in. So in this case, I have 3 things. I've got to bring that exponent up on the 1/2 on the exponent. So that's really going to be x to the 1/2, which we saw in the previous example is going to be the square root of x.
Yep.
Okay.
Somebody always asks me this question, Miss Young, do I pull a negative up as an exponent? And the answer is you can. But if you pull that up, it becomes addition, and it becomes a negative exponent, which will flip to the bottom of the fraction. So don't do it, because you're going to end up in the same place, but it's going to take you extra steps.
So if we can do this without causing too much grief, it's going to be log. I'm going to try to do it all in one step because I'm dying here on my iPad. I'm going to have the square root of x. And then I'm going to have a z squared.
So he's putting z squared next because it's positive. So that means that's what's getting multiplied. And he's putting y in the bottom because it's minus. And so that actually means division. Remember that this subtraction is telling you actually to divide, and this, yeah, which goes to the bottom of the fraction, and this plus is telling you to multiply, which stays in the top of the fraction. So when the logs are positive, to the top, when the logs are negative, to the bottom.
And I think we are kaput.
Kaput.
There are your practice problems. Sorry for my internet issues. Happy Wednesday or whatever day it is you're watching it.
Bye, guys.
Bye.